Hi, I'm Devansh Saxena, a PhD student in the Department of Computer Science at Marquette University. Today, my colleague Patrick Skeba, a PhD student in the Department of Computer Science and Engineering at Lehigh University, and I will be presenting research we are conducting with our mentors, Dr. Shion Guha at Marquette University and Dr. Eric P.S. Baumer at Lehigh University on the methods for generating typologies of non-use. Growing body of research has shown that a binary distinction between users and non-users is insufficient and that we observe myriad forms of disengagement in practice. This makes it hard to develop a single definitive typology that accounts for all these non-use behaviors. We often find ourselves caught between rich but uncodifiable collection of practices recognized by qualitative methods and oversimplified classification schemes developed by quantitative methods. So can we possibly combine the two methods to generate more robust typologies? We conducted a survey about Facebook non-use via Qualtrics and asked questions about non-use practices derived from prior literature. We also asked questions derived from 5 psychometric scales, as depicted here. We used a data-driven approach to find the most prevalent types of non-use and focused on the top 6 non-use types. C2, for instance, is a non-use type where the participants currently have a Facebook account, but at some point voluntarily took a break from Facebook. This method uses all 7 non-use questions, but limits the sample size by excluding data points in the long tail of the distribution. The taxonomic tree method is a data-driven process that allows for qualitative interventions based on the research criteria. In our case, we devised evaluation criteria based on the intensity of non-use behaviors, with permanently deleting your account being the most intense and voluntarily taking a break being the least intense form of non-use. This method preserves the sample size but only uses 4 non-use questions. A theoretical mapping exists between the two typologies. For instance, the curve-fitting type C6 maps onto the taxonomic tree type T5 because participants who had engaged in the more intense forms of non-use are also more likely to have engaged in the less intense forms of non-use. Our data shows that participants who had permanently deleted their Facebook account had also engaged in other non-use behaviors.
In order to compare the effects of applying these two strategies, we built 2 logistic regression models with classes from either the curve-fitting or the taxonomic tree typologies. In our paper, we discuss in detail the process of feature engineering, but basically we used factor analysis to extract features from the 5 psychometric scales and then combined this with the demographic features from the survey as well. For each of these models, we used a stepwise process to remove features which did not significantly improve the model fit. This table shows the odds ratios for 4 factors that were significant in both typologies, where the base classes C1 and T1 are current users with no non-use behaviors. What we want to emphasize here are the convergences and divergences between the statistical relationships in the two typologies. For 2 features, relapse and age, the odds ratios are in the same direction and approximately to the same magnitude. On the other hand, daily routine and effective gratification have odds ratios in opposite directions, positive for curve-fitting and negative for taxonomic tree. These similarities, and especially the differences, can reveal insights into the data which would be hidden if only a single typology were used. To investigate these divergences more closely, we made one final comparison using a typology from Baumer et al. 2019 that was constructed manually. We found significant alignment with the taxonomic tree model, but not the curve fitting. This hints at a potentially interesting but subtle difference between our 2 typologies that would make for good future research. The main goal of our study is to offer a holistic methodological approach for typology generation, which can reveal insights that might be missed if a single a priori typology were chosen. We generate 2 separate typologies through different statistical means, train models to predict those classes, and compare the results. When features have similar significant effects as with relapse and age in our study, it can increase our confidence in the predictive power of those features. When the models do not agree with each other, it can suggest subtle differences in the typologies that need revised, or add skepticism to those features' significance due to their lack of stability. This process of inspection can help to further refine our typologies, potentially leading to more robust results with more stable outcomes and higher effect sizes. In summary, the curve-fitting and taxonomic tree methods presented here offer different ways to operationalize complex theoretical constructs in a data-driven manner. Each of these methods on their own have potential to generate typologies for theoretically tricky or immature constructs, but results which align with both are likely to be more consistent with reality than those that align with only one. Thank you. We hope to get some questions from the audience, and our contact info is on the screen to reach us later.